Good evening. Thank you for being here. It's 4 o'clock, day 2. You must be a really, really committed human being to be here. But thank you for being here. Thank you for your time and attention. My name is Anand Venugopal. I lead the StreamAnalytix product business in Impetus Technologies. As you might have noticed, we are a diamond sponsor in this event. So thank you for being here at this event and making it valuable for all the sponsors and learning whatever you learn. So hopefully you learn some more in this session. So I'm going to tell you about a story of how a major bank leveraged Apache Spark and our product StreamAnalytix to rebuild their insider threat detection application. And we were going to have a co-presenter with the bank themselves. Due to last-minute legal issues, we couldn't have them come and present. But I have the second best solution compared to that. He's here in the room, and you can talk to him at the end of the session if you have questions, right here in the front row. So let's get on with the case itself. If you don't know who Impetus is, we're a big data products and services company. StreamAnalytix is one of our products. It is a streaming analytics platform based on Storm, Spark, and other new technologies like Flink and TensorFlow as well built in. So I'll give you the use case background, system challenges that were experienced with the old system, and then what happened with the new system and what the benefits were delivered, etc. So let's think about this for a minute, right? What are the most important things in your life that you need to protect? I would think family, your own physical well-being and family. Second, your money and assets and your information, right? Now, a bank is a custodian, is our custodian of our assets and our money and our trust. So it's obviously important that for us, our bank protects our money and financial information really well, right? And thinking about the bank and what the cost is and impact is for them to protect insider, protect the information, our information and our money, it's obviously huge because the reputational risk is very large, especially if you're a very big bank who is global, who is over in 40 plus countries, more than $1 trillion in assets under management, and with 4,000 retail centers, we all know this bank and probably doing business, many of us probably doing business with this bank. So it's obviously important for us as consumers that this information is protected very well. Now, speaking of the nature of insider threat itself versus external, there was a survey done by Accenture, and even though 78% of these IT people in the finance function said, they were overall happy with the cybersecurity, a lot of them had doubts about the internal breaches, right? There's more than 52%, and nearly 50% said that an internal breach would be as bad or worse than an external breach. Naturally, because these employees that are having bank applications have access to your credit, have access to your information, they could do a lot of damage. So the other aspect of this is 2/3 of breaches are found to be from human error. So that means, one, it is detectable and fixable. That's the good news, right? So the kind of insider threats that normally happen are, employees mishandling confidential data, in general, lack of system controls, right? People granting themselves potentially privileges, old unused IDs, people using applications, like for example, pulling credit. A person that has access to the mortgage system could go and zero out his own outstanding loan amount. Anything could happen, right? And some activities could be malicious and some could be purely accidental. So responding to phishing emails, download rogue programs, or they're doing something without their knowledge that's violating government regulations, all of that needs to be protected internally. So how does one do this? What is the flow of an insider threat detection system? So there's users that are performing actions in bank applications or doing SQL queries on databases, things like that. So those all activities are logged. They're moved from all of the different sources from where they are acting to a central location in near real time, and then they're analyzed and marked for alerting and communication. So based on a very, very complex set of rules, the decision is taken whether this is potentially a threat or an interesting event, and then it is communicated out to that person's manager and management chain. So that's the overall layout of the case itself, right? The owner of this particular use case in this particular bank is called the instrumentation team in this particular bank, and like I said, internal app logs are analyzed for suspicious activity. And the rule set that is being applied is obviously very complex. It's been learned over time what are threats and how they work. So all of that residual intelligence building over many years has been coded into a set of very complex rules. And as events come in, these rules need to be applied, and the absolute worst case legal limit where our friend here would get in trouble would be 5 minutes, all the way from the detection of the event to the event coming in, stored, analyzed, and recorded into the final database. But typically, 30 seconds is what is expected, and we're doing it now in about 15 to 18 seconds, end to end, including all of the hops, and I'll tell you a little bit about all that journey of each record coming in. So it's obviously real-time detection and alerting to the management team. So now let's look at the complexity of what this use case is in terms of numbers. So the current full total addressable set of applications that need detection are about 5,000. Up until last year, they had 1,800 of them covered under this, and because of the new system, they were able to now bump it up to about 2,500 plus sources. So 2,500 plus applications world over are sending data, sending logs, up to 40 million records a day, and the peak value is about 16,000 events per second. So once the events come in, there's data quality rules to be applied to see whether there is enough minimum quality in that record to even act on it. And that computation is done, and those rules are dynamic. And once that is done, there's a 7-day dedupe window. So if any record is duplicate within the last 7 days, it's got to be discarded and not acted on. And for every record, just to match the ID, the user ID to the right employee, there's about 10 different rules to actually establish an accurate match. So you could have about 9 or 10 lookups from the cache for every transaction. That's the worst case. And the logic in the rules have a 24-hour window. So if this happened, that didn't happen, plus that happened over the last 24 hours, then this is a suspicious event. So you need to maintain that kind of a cache, and real-time compute plus cache requirement at that scale obviously makes it a fairly complex system. So what was the problem? Why did they need to replace it? They replace an existing solution, right? So the story goes that somebody in the bank knew somebody that they had worked with, and they gotten this open source system, which I don't want to name, the previous system that was in operation. So the current staff didn't really have a say of when this insider threat detection software was chosen and when it was implemented. But it was implemented because somebody knew somebody, and 6 weeks was the implementation time. They implemented it, and the challenge was, once it was implemented and got up and running, to keep it up and running was a challenge. Every time this team had to bounce the system, restart, check logs, debug. So there's plenty of stability issues in that system, resulting in a lot of downtime, and you don't want that kind of unreliable system doing your insider threat detection. And the processing rate was often slowing down compared to the incoming rate of records, and there was a lot of backup. And every time there was new functionality, the implementation was done in a very rigid way, which was all code-based, hard coding as opposed to configurable rules. So this team had to pretty much become the QA team of that particular product company. So they also didn't see the vendor really supporting the product and having a future for this product. So this team really started looking out for options. And we showed up on the radar, again, because we are an Apache Spark based solution, and one of our senior employees knew somebody in the bank, and that's how we got in. But then we were rigorously tested against competition, because it was bank policy to obviously test at least with one or two competing solutions. And the team was incredibly happy to see how fast we were able to recreate the whole logic and get up and running to a fully prototyped system after the POC in 4 weeks or less. And when they put the same case against the other vendor, who is also a fairly popular real-time data integration vendor today in today's market, they took about 10 weeks for the POC. And it wasn't Spark, it wasn't open source based, it was a proprietary engine, so that was the other issue, and there was a lot of custom coding required. Whereas in StreamAnalytix, it's a drag and drop interface. Basically, there was almost very little code to be written. There was some custom coding, but a lot of drag and drop features were used. I'm going to get into the pipeline as well. And we achieved a performance of about 18,000 events per second, whereas the max performance achieved by the competition was about 7,000. And this itself delivered about a 3.3x increase over the old system. And Apache Spark itself guarantees, reliability, exactly once processing, and complete scalability. So it's elastic scale. So there's straight benefits that we inherit from the Hadoop Spark stack that we reflected in the application. And those were all the benefits that finally had them choose to move forward with a Spark and StreamAnalytix based solution. So let's look at what this solution itself was. So I'm going to take some time kind of walking through this, because it's the basis of everything. So these 2,500 different bank applications are moving data into a NAS system, network access storage, and this gzip text files. We wrote, there was initially, again, that the other third-party vendors piece that was taking that data onto and moving it through Kafka onto their analytics system, which we eventually replaced. So we wrote wrapper code around Apache Flume, moved the data from the NAS system onto Kafka. The bank also needed to track the metadata associated with the records. So how many records are being processed, how soon, how many are erroring out, how many duplicates. All of that metadata had to be tracked. And so there was, as you see, we were forking that into two topics. They were generating some metadata, writing that into another Kafka topic that was processed independently in pipeline B. And the raw data is going through topic A and into the main pipeline on Spark. And so that's the whole multi-stage pipeline that I'm going to get into next, which has deduplication, data quality, and the actual alerting rules that has been scaled up and is now accepting all of that data pretty much 24/7. Because of state management being a big need and associated with real-time compute, StreamAnalytix has always been compatible with Couchbase for distributed caching, and that's proved to be a good decision. It's satisfying the needs of all the caching windows that I talked about, time windows, 24-hour windows for the rules, 7-day windows for the dedupe, etc. So ultimately, the output of the system goes into both SQL Server and HDFS. SQL Server maintains a 7-day storage, and then HDFS is the long term. So that's the overall high-level view of this pipeline here. What's really happening inside is a little more detail. I can walk through that also. So this is actually a screenshot of the Spark pipeline as you see it on this tool, StreamAnalytix, where you literally basically build these pipelines by drag and drop, right-click, configure, and test as you develop, and iteratively build your application flow. So as you can see, we are receiving from Kafka from the raw topic, the pipeline A, and we do the dedupe using the cache with a 7-day window. And if it is found to be duplicate, it goes into marking the cache again after the fork below. If it's found to be a unique non-duplicate record, it goes through for processing. And we first calculate the data quality score using a set of rules, which again we said needed to be dynamic. So there could be changes in the DQ rules itself that needed to be updated in real time if there was a change. So that was again undoable in the previous system. What we do is we use the combination of Zookeeper and Spark to do things like that, where we can dynamically keep sensing any changes, and so we do that now. So that's the big advantage there. And the enrichment operator is where we do all our ETL, blending, lookups, etc. So that's standard operator in StreamAnalytix, which has all of the ETL rules and data enrichment and blending implemented in that operator. And further on, that's we in the alert operators where we now classify whether this is an insider threat event or not, based on a very, again, an elaborate set of rules. There are some events that need to be triggered immediately into an alert. There are some that can wait for a day. For example, if somebody pulls a credit report or something like that, it can wait. But if there is a login from an unauthorized system, or there's an employee that has actually left the company and there's a login happening from that employee for some reason, or if there's a series of logins happening from different devices in a certain amount of time, there are certain of all those kinds of immediate alerts that need to get immediately passed on to the management chain. So there are categories of alerts there in that alert operator. It's all built in. And the interesting thing is all of these are standard operators. There's no custom coding at all here, and that's the part of the beauty of this system. There's very little custom coding to do. So you can build pretty strong, sophisticated Spark applications, both streaming and batch or a combination, with this product without writing custom code, without getting into Scala coding, etc. So we finally take off sync the data into SQL Server and HDFS, and that's the whole pipeline. But we've shown that for indicative understanding here. There's actually another pipeline that reads out of Kafka and then writes it into a SQL Server. So there was a lot of lessons learned. I'm going to come to that. But the benefits of having deployed this application, and we'll have a technical Q&A as well. Our solution architect Puneet is here as well to answer any deeper questions if you have it. But the key thing is, our friend is here in this room. He's at peace. He doesn't have to worry, and that was not his situation earlier. There was a whole FTE, there was a whole employee, I think, and a couple of people just dedicated to finding bugs and literally being the QA team of the previous vendor. So there was a lot of nightmare, and we have been involved in, and we've seen that ourselves during the whole project of replacing the system. We took about 3 to 4 weeks to do the POC and then get it to final production. In less than 3 months, it was in production. The whole new system, right? So it was approximately 1/5, 1/6 of what they used to spend is what they're going to be spending with us. With additionally, there's an entire employee that is no longer doing this work. They're doing other interesting work, as opposed to raising tickets and debugging the insider threat detection platform. Because of the performance gain, with the same amount of hardware, which is about 3 to 4 Spark nodes, they are now able to onboard 800 new applications. In this year, they've just onboarded that with 0 new hardware. So that would have been a big another spend and an opportunity cycle in terms of time. So, like the FedEx person said today in the keynote, there's a lot of benefits of this technology, the big data technology, that are tangible. There are some that are intangible, right? So peace of mind for your employees and a better, reliable, stable system for your insider threat detection. There's probably immeasurable benefit there. So in terms of certain nuances that that were discovered in the system. So I talked about dynamic data quality rules that had to be updated with no downtime. So we actually take regular expressions from the SQL Server from our database where we update the rules. You could go to that pipeline view, go to the data quality operator, change the rules, and hit update. We'll read the change dynamically, update it in the running pipeline. You don't need to stop it, and it'll just continue action. Similarly, we could do that with even predictive models or other configurable items. State management was very important for rules, and dedupe at scale was required. And you saw the scale was 16,000 at peak events per second. So Couchbase again was a good partner technology for us with Spark and Couchbase, and like I said, we've integrated over time. We had to generate a unique ID for each record, and that could not be duplicated at all. And we're reading sometimes from multiple partitions, so we created a range for each partition. There was an issue at some point which we had hit a bug, and we had a duplicate set of records that came in, and we debugged that. And that was another learning for us. The ingress performance on the NAS side was a big bottleneck. It just would not deliver the records as fast as what we wanted to read into Kafka. So with that Flume system, we actually did a 4-way replication into the Spark nodes directly. So we wrote all the data and into the file system of the Spark nodes themselves and read directly from there. So that was another issue encountered and solved. And the egress performance tuning was also an issue. The SQL Server at the destination side was supporting reporting jobs, and it was in conflict with writing. So to do the whole performance tuning, we simulated that load of the external reporting jobs in the pre-prod environment, and we tuned the whole pipeline to write at speed and deal with other conflicts in SQL Server, and that tuning was an interesting learning from this. And it was important for us to count the velocity of the number of records, number of duplicates, number of errors, all of that in real time, all the time. So we actually have another pipeline itself doing that counting. So in terms of just recap of advantages of the StreamAnalytix product, it's based on Spark. It works with Hadoop and the cloud. So it's a natural fit. A lot of banks and a lot of telcos are using this. It's in production at a major telco as well. People want to use open source. People don't want to deal with writing code and managing and the cumbersome aspects of managing the open source itself and having a lot of hyper-skilled engineers. So this literally lifts the barrier of skills required to deal with having an enterprise-grade open source streaming and machine learning platform. So we've just gotten a patent awarded for the extensibility feature we have. So you see all of those operators there that you saw. You can actually create custom operators, custom models, custom functions, and add them into this platform. It's totally extensible and can be shared across the development team. So an out-of-the-box state management coupled with Apache Spark is a huge benefit that was used here. And often banks in a regulated environment need to see, audit, what happened to a particular record, where did it fail, or if it's a credit card application approval system, why did this particular person get denied? You got to have that answer. And where in that pipeline, which logic did failed or worked the other way. We are able to provide that kind of audit inside of Spark. So at an operator level, we go down to where this particular record was either failed or took a decision to say yes or no. So that kind of audit is important for a bank, and we support that. And Spark application tuning, monitoring, and runtime is a big deal. In such a scaled out system, you want to know if things break, how fast can you detect a problem of slowing down a pipeline, where the issue is, which line of code is broken, etc. We provide you all of that way above vanilla Apache Spark in terms of monitoring. We give you the Spark UI as well as a lot of value adds on top of Spark. Naturally, the stability and reliability question was solved. It's running at full capacity from many months now, and so that problem was solved. And this really enables a lot of new things in the bank. They're going to upload eventually 2,500 more applications to complete out the full coverage of insider threat. So that will come to a total of 5,000 different applications across the world sending logs to this system. Starting from complex set of rules, there's obviously a direction in the bank to use more AI and deep learning methods. We support TensorFlow as part of our system. So that would be supported, just like I think somebody was talking about today in the keynote again. You can go that far with linear rules and with ML, but with deep learning, you could actually build things that you can never anticipate manually. So the system will actually now start revealing new threats, new ways of detecting threats. So that's possible, again, with StreamAnalytix because we support TensorFlow. And a lot of accessory use cases, like if a user is now authorized to use application X and has not been using it since 6 months, why should he have that permission anymore? So that's becoming visible now with this application. The data science team is actually taking the output of what we are generating and then building their models and raising new alerts with that. And when you've solved insider threat, insider trading can't be far behind. So that's one of the use cases, again, in this bank that's coming up soon. That's going to be targeted for the same platform. So that's also part of the roadmap. So I'm giving you some time back. That's pretty much the end of my presentation. So I'm open for questions. If it's technical, we'll have Puneet come up and answer some questions. And once I step down, we can chat casually with the bank representative here as well if you have questions for him. But I'll be happy to answer questions. You good?
Are you using StreamSet? Spark StreamSet?
No, we don't use StreamSet. So we.
It's all stream. Meaning like batch. It's all streaming data.
It's all streaming data. It's Spark streaming, if that's what your question was. Yeah. We use Spark streaming in this case. And we've upgraded StreamAnalytix to support structured streaming, which is Spark 2.2, and which has event time support, watermarking, etc. Anything else?
Are you running any streams on your Kafka topics?
Say that again, please.
Are you running streams on your Kafka topics, or are you running streams in the cluster?
We're receiving from the Kafka topics into Spark and doing all the streaming, processing, and analytics on Spark. So kind of show of hands, are you working on a similar use case? If you are, let me know. Are you? I know there's one.
I'm doing it for security, so.
Okay.
Or across different sources, lots of different sources.
Lots of different sources. Got it. And are you here because you're evaluating Spark from a streaming point of view? Is that the case? Got it. Cool. Well, thank you so much for being here, and we'll be here for some more time. If you want to come in and talk to us, that'll be good. Yeah, Larry? Absolutely, that's very important. So you could see more about this product on this website, streamanalytix.com, and impetus.com is the actual company. If you want to see a demo of this solution, we are here tomorrow as well. We can give you a full-fledged demo and deep dive into this product, and we have it in our booth. How many of you actually visited our booth already? Yeah? Okay, cool. Yeah. StreamAnalytix is available as a free download as well. It's called StreamAnalytix Lite. It's a less than 1 GB package. You can download it in a few minutes depending on your bandwidth, and within about 7 to 8 minutes after the download, you'll be building Spark pipelines. So that's how easy it is. It's a single node version with Spark packaged, StreamAnalytix packaged in it. There's ready-made templates. So especially if you're learning Spark or if you want your team to get more productive with Spark, this is a fantastic system. So there's a light version of this product available.
Features.
Say that again, please.
That light
Yeah.
Other than functionality around single node, does that have include all the
Yeah, it includes all the functionality of the product, and you can deploy Spark pipelines to a single node in local mode, and you can get all the functional power of one single node. You need the enterprise edition to deploy to a multi-node cluster. Sorry? The StreamAnalytix product is not open source. The operators that you see are all pre-built code, and you don't have real access to seeing that code. You have access to what it does in terms of logs, etc. And of course, if you have custom logic you want to put in, it's your code, so you can add that in as well. All right, thank you.